Hey everyone, today we're going to talk about domain, range, and end behavior. If you are looking at your online textbook, you can follow along with this lesson. This is lesson 1.1. Alright, so today we're going to talk about domain, range, and end behavior. Alright, so if we scroll down through here, we want to know how to represent an interval on a number line. So in past courses, you graphed inequalities such as x greater than 1 by drawing an array on a number line. Note that this describes an interval. An infinite or a finite interval has two endpoints, which may or may not be included in the interval. So a finite means it stops. Okay? An infinite interval is unbounded, which means it continues on at least one end. So your vocabulary, an interval is an unbroken portion on a number line. All right, vocabulary in this class is so important, so I hope that you take time to take notes. Make sure you look through and work on the vocabulary and learn the symbols and the vocabulary. If you do that from day one, it will make this class much easier. If you don't understand the vocabulary or the symbols, then it will be much more difficult. Alright, so it says you can represent an interval using an inequality set notation or interval notation. So that means there's two different notations that you're going to have to know. Alright, you got to know set notation and interval notation. In set notation, you're going to see the set symbols like right here it's given. So this reads the set of all x. So the set of all x, and this line means such that x is greater than 1. All right, unless otherwise indicated, it is assumed that x is a real number. To specify a domain for a real number set, the notation x such that x is an element of all real numbers. So if you see the R there, that just means it's all real numbers. And this symbol here means is an element of this set. All right, so several symbols here. All right, interval notation encloses endpoints in parentheses or brackets. So when you have an interval notation, you're either going to have parentheses or brackets. A parentheses indicates an endpoint is not included in the interval, and a bracket indicates that an endpoint is included. All right, so that's very important. Make sure you make a note of that, because all year when you see set notation and interval notation, you're going to need to know what the parentheses means, what the bracket means, and what the set notation means. For infinite intervals, use the infinity symbol, positive infinity, and negative infinity. All right, so positive infinity, if you think about a number line, positive infinity is going to go to the right on a number line in the positive x direction. Negative infinity is going to the left in a negative direction. All right, an interval of the form, the parentheses, a plus infinity, or a to positive infinity, is unbounded in the positive direction. So this one's open circle if you were graphing it, and this one would have a closed circle because of the bracket. Okay, so this means the endpoint is not included. A is not included in this interval. This one means A is included in the interval. And both of them are unbounded in the positive direction because of the positive infinity sign. An interval of the form negative infinity to A or negative infinity to A with a bracket is unbounded in the negative direction. So again, A in this case is not included in the interval. The bracket means A is included in the interval here, but both are unbounded in the negative direction because of the negative infinity. So x greater than 1 written in interval notation is x is 1 to positive infinity. All right, if you were to graph these, finite, this is finite because it's a segment, like it stops, okay? These two are infinite. This one is infinite in the negative direction. This one's infinite in the positive direction. That arrow means that it continues on forever. So finite, it stops. Infinite, it continues. Inequality notation. Hopefully you've seen inequalities in the past. So you can see this is an open circle. That means it is just strictly less than. This is a closed circle, which means it's less than or equal to. Same thing, open circle, less than, closed circle, greater than or equal to. All right, so these are examples of what this is. This is an example. This is what it's going to look like in set notation. This is what it's going to look like in interval notation. So right here, this says the set of all x's such that x is between a and b, where a is not included and b is included. Okay? In interval notation, it's kind of like a shorthand, but you have to know what the parentheses and the bracket means. The parentheses, again, means it's an open circle, and a bracket means closed circle. That means it's not included. This means it is included. All right, same thing with these. This would be set notation. This would be interval notation. Very important. You're going to use these in any math classes that you go in this class and beyond. So the better you understand it now, the easier it'll be moving on. All right, so let's see if you can match these. I would like for you to stop the video. Just pause the video for a moment, answer these questions, and then click Start again. All right, check to see if you got these correct. Hopefully everyone got these correct and we can move on. All right, for B part, an interval is modeled by the graph shown. Select the set notation and the interval notation that describes the interval represented. So you want to select two answers. So this is a select all. It says select the set notation and the interval notation. So we can look at the graph here and we can see that this is an open circle and it's shaded to the right, which means it is greater than. So again, pause the video, check the ones that you see, and then start again. All right, so if you looked at the graph, you can see that this is open, so the -1 is not included and it is greater than. So this is less than, this is greater than or equal to, and this one is greater than. So this one says x such that all x greater than -1. So this is your set notation. And then we need to find one of the interval notations. This says it goes from -infinity to -1. Well, -infinity is to the left, so that's not correct. So then you come down here and say from -1 to +infinity. -1 is open, it's not included. All right, so that is the correct answer. This one's the same, except this shows that -1 is included, so those are the two correct answers. All right, again, pause the video, try to answer this question, and then we will answer it together. All right, so this one says, suppose that the graph is changed so that x equals -1. The open circle becomes a solid circle. How do the set and interval notations change for the new interval? So you're looking above here where we had x is greater than -1, and we simply want to change that to a closed circle. So that means now it's greater than or equal to -1, and we have the bracket. So check your answer, make sure that you got that, and ask questions if you need help. All right, last question. Pause it, and then we'll do it together. All right, again, this is C part, so we're still looking at the same graph from above. It says, think about how you can describe the set of all real numbers not shown in the graph. So if you look at the graph, they want to know, how can you represent all the numbers not shown? So we need everything less than or equal to -1. So think about which set represents less than or equal to -1. So here we've got less than or equal to -1, and here it has a bracket at -1. So it's going to be the set notation of x such that x less than or equal to -1, and the interval notation is -infinity to -1 with a bracket. All right, so that's what we've got for set and interval notation. I hope this was helpful. If you have questions, please ask me.